Hi, welcome along to some maths all about volume. We're going to have a look at some volume of cuboids, cubes, look at how we can reason with that as well today. One of the big things that we're going to need to remember for this today is going to be that volume equals length times height times width, or however that comes, because it's all multiplication. Use the commutative rule. Any of these can be in any position, you still get the same answer. Question number 1 is fairly straightforward. Cuboid is made from centimetres cubed, 3 centimetres by 4 centimetres by 2 centimetres. What is the volume? So we go back to our formula, length times width times height. Okay, so we have 3 times 4 is 12, times 2 is going to give us 24. However, interestingly, in the answer box here it says centimetres. We know that as a volume that needs to be centimetres cubed. So I'm going to fix that there and pop that in there. Bonus point if you did that. Another cuboid is made from centimetre cubes. It has a volume of 30 cubic centimetres. What could the length, height and width be? So for these, again, my advice for these, always make them as straightforward as possible. And interesting, look, we had centimetres cubed here. This is a really badly written question by the exam board. They missed the cubed off the centimetres here, but they've put it on here for height, length and width, which is a single dimension. So, ignoring that, to make this as straightforward as possible, you could simply put in 30 and 1 and 1. Okay, and you're going to get 30 centimetre cubed there. Any dimensions that you put in here, when you multiply the 3 together to get an answer of 30, will be the correct answer. Question number 2, cuboids. These cuboids are made from small cubes. Write how many small cubes there are in each cuboid. The first one is done for you. This is simply asking you to find how many small cubes. That's the same as asking you to find the volume. You can do that either by counting, but that's not the most efficient method. The most efficient method will be to use our formula back here. Volume equals length times width times height, or height times width times length, however you say it. So let's have a look at this one then. We have got 5 multiplied by 2 multiplied by 1. 5 times 2 is 10, times 1 is 10. So that's going to give us 10 cubes. Here we have 2 and 4 and 2. So if I multiply those together, 2 times 4 is 8, times 2 is going to give us 16 cubes. Here, and then for our final one I have 2, 3 and 5 as my dimensions. So I can do 5 multiplied by 3 gives me 15, multiplied by 2 is going to give me 30 cubes for this one. Nice and straightforward. Quite an easy 3 marks there really. Okie doke. And then we have B, which is the next part of this. The shape is made with 2 cuboids. Right, how many small cubes there are in this shape? What I would do here is you need to split this, and you can choose kind of where you split it. You can either kind of split it along that dimension there and split out the top here. Split out the top from the bottom, or you can look at that the other way and you can kind of split it down here and split this section off here. Either way you're going to get the same answer. Because it's a compound shape, you deal with it like it were a compound area, but this one's simply just a compound volume. So here, don't want to move that, let's drop that back. Here I have got, let's have a look, I've got 2 by 2 by 2 is my little cube here, so that's going to give me a volume there of 4 in this section, and then I've got another one here which is 2 by 2 by 4, so that's actually going to be 4 multiplied by 4, which is going to give me 16. So then my total number of cubes here is going to be 16 plus 4 is going to be 20. Okay, cube A and cuboid B have the same volume, so we need to calculate the missing length on cuboid B. Now, initially when you might look at this question, you might think to yourself, hang on, I don't have enough information here. Well, you do, because you're told that A is a cube, and that means you only need one length to be able to work out the volume. You need to know what 6 cubed is, and you can work that out by doing 6 times 6 times 6, or you know simply that's 216 centimeters cubed for our volume, like that. So then that means I need to, that's going to be the same for B. And I know I have 2 dimensions, which means for my volume, let's pop our calculation back in here. V equals length times width times height. I know if I'm using that calculation here, I know that I have the volume, it's 216. I have my, let's call this height, that's 4. I have my, let's call that width, that's 6, which means actually this dimension here that I'm missing is my length, which is this question mark here. Okay, if I know that, I know that if I work out what my width and my height is, what 4 times 6 is, so 4 times 6 is going to be 24 here. I know that my V, my volume, if I pop this over here, is actually now just the same as my question mark length times 24. So I just need to know how many times how many times 24 goes into my volume. So it's 216 divided by 24, or it's how many times 24 I can get to 216, and you'll get your missing length there of 9, because 9 times 24 gets you to 216. 9 times 24 equals 216 centimeters cubed. Pop that in like that. That little up arrow means it's cubed if I write in too quickly to make it into the superscript above it. So that's how you work that out. You kind of just rearrange. You use what you know, you rearrange it, you backwards work it, and you get your answer out at the other end. Okay, let's jump into question number 4. The cube and the cuboid have equal volumes. Very similar question. You'll see a lot of these popping up like this. Again, cube, I only need a single dimension. I know what I have there for all of my length, height and width. So there we know that 12 times 12 is 144. I know that 144 times 12 is 1,728 centimeters cubed. So pop that in there, give myself a little smaller 3, don't want 3A, like that. Okay, so that's my volume. That's the first thing I know here. Now actually I can look at the other side here, and it says ask me to calculate the height of the cuboid. So I'm going to use my same formula here again. V equals L times W times H. I'm going to bring this over here. Now it says here it's asked me to calculate the height, which means I've got the volume because it's the same, they have equal volumes. I've got my length, I've got my width, I do not have my height. So that's my missing one. Okay, so I'm going to go through the same process as I went through before. I know my length, it is 16, I know my width, it is 6. So I'm going to multiply those together and get my answer. So I'm going to do 16 multiplied by 6, which is going to give me 96. Okay, in here. So now I have my volume is 96 multiplied by my height. Okay, which means I'm going to need to do the inverse to work this out. I'm going to need to start with my volume, 1,728. I'm going to need to divide that by 96, and for that I would use my formal method of division. That's why I'd be given this working out show your method space here. So I'm doing 1,728 divided by 96. That's going to give me my height of 18 centimeters. Okay, so for that one you are going to need to use your long division method, you are going to need to use your formal method, and we know for that the most effective thing to do would be to write out your 96 times tables. And in order to do that, that's a nearly number, that's 100, so you just add 100, subtract 4 each time, and you'll quickly get your 96 times table written out, and then you'll be able to simply divide 1,728 by 96 to get your answer. Okie doke. Question number 5. A cuboid has a square base. That is important. You know it's important. It's written in bold. It is twice as tall as it is wide. The volume is 250 centimeters cubed. There's something here that you need to spot. This is where you need to identify things. This here, square. and this number here. If you know your square numbers, you would recognise, hopefully in there, that actually 25 is a square number, and 25 is a factor of 10 smaller than 250, which is really interesting. Now it says here it's twice as tall as it is wide. We know it's a square base, we know that's going to be a square number. So if I listed my square numbers, I might have 1, and then I'm going to have 4, 2 times 2, then I'm going to have 9, 3 times 3, then I'm going to have 16, not 15, I'm going to have 16, 4 times 4, then I'm going to have 25, 5 times 5, etc. And what I could do is I could do a bit of a trial and error with this, but actually if I'm identifying, if I'm spotting that link in there, 25, hang on a sec, well if I had, let's try that out, if I popped in down here 5 centimetres and 5 centimetres, that would give me a square area on the bottom of 5 times 5, which is, let's try and get the parallel, 25 on the bottom there. And then to find the height, to find the volume, well, I know it's 250, or 25 times 10 is going to give me 250. And actually, if 10 was my height, that's twice as high as it is wide. So those are my dimensions there, 5 times 5 times 10. 5 times 5 is 25 times 10, 250 cubic centimetres. Okay, so you can get there with some trial and error. However, if you inspect that, if you identify that, if you're spotting those links and those relationships, if you're spotting that square base, and if you're spotting that 250, and you're identifying that as having a link with a square number, that's where you're going to get a much more efficient solution to these problems. Okay. That's the end of 5. Let's jump into 6. Okay, so we have 2 cuboids of the same volume. Calculate the length. X is not to scale, you can't measure it. Where it says not to scale, you can't measure it. So we're looking for X. X is here. Because X is here and here, that means that this face is going to be square, because it has the same dimensions. That helps me out a lot. Okay, so they have the same volume. So obviously, first of all, I'm going to work out the volume of this one here. Okay, we know that volume is length times width times height. So if I just pop those numbers into a calculation, 6 times 5 is 30, multiplied by 10 is going to give me a volume of 300 centimetres cubed. Drop this one up here, there we go. Okay, so I've got 300 centimetres cubed. That is the same as the volume over here, because both cuboids have the same volume. Now I have here, my length and my width are going to be the same number. So I've got something multiplied by 12 gives me 300. So if I do 300 divided by 12, I get an answer of 25. Now that 25 is not going to be each x. 25 is going to be this square area here. 25 is going to be the square area of the square face at the end of my cuboid. Now again, like with a similar question, previous question, you'll notice, and you should spot straight away, 25 is our square number. And if I find out what each dimension is going to be, it's going to be the same. So that's going to be, each x is going to be 5. It's going to be 5 times 5 is 25. And then if I put that back into a calculation, 5 times 5 times 12 is going to get me back to 300 centimetres cubed for my volume. Okay, question number 7 with salt. Fascinating salt. We have the volume of this standard box of salt. So we have 5 times 6 times 10. Hang on a sec. Yeah, 5 times 6 times 10. That's a really bad diagram. Look at the difference in dimensions between 5 and 6 centimetres, and they're only a different centimetre apart. Doesn't help us. Yeah, same, almost this very similar question here. So we've got 5 times 6 times 10. 5 multiplied by 6 is 30, multiplied by 10 is going to give us a volume here of, let's pop it into the box, 300 centimetres cubed. And they've put the correct unit of measure, which is excellent. So what is the volume of this special offer box of salt, which is 20% bigger? All I need to do here is find 20% of 300. So 10% of 300 is 30, which means that 20% of 300 is 60, but then I need to add those two together, which is going to give me a total volume of 360 centimeters cubed. So percentages work with numbers, percentages also work with volume. It's exactly the same principle. Okay. The standard size box of salt contains enough salt to fill up 10 salt pots. How many salt pots can be filled up with a special offer box of salt? Okay, so if we're thinking percentages, this is 20% bigger, fine. If I think here though, this is interesting, and again, this is all to do with identifying, it's all to do with spotting your links here. If I think about this, if I've got 10 salt pots here, that kind of says to me that, well, each one of these is going to be 10%. So if I drop each one of these as a 10%, that's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So 10 salt pots, well, if I've got 20% extra more, each one of those is 10%, so that's going to give me an extra 2 salt pots. How many more salt pots can be filled up with special offer box salt? 2. So it's going to be 12 boxes in total. Okay, and then final question, calculate the volume of the prism. Tricky one, but think of it exactly the same as a triangle. So the volume of a triangle, the area of a triangle is half of the base times height, which is the same as our kind of length times our width, if you will. So this is my height here. So I can work out the area of the triangular face, and then all I need to do is multiply that by how deep it is, which is this figure here. Okay, this number on the top, 5 centimeters, is a bit of a red herring. You don't actually need it, it's not going to help you with this here. So what you can do, and what I would actually do if this was me and I was answering this question, would be just to cross that out so it doesn't get confusing for me. So the first thing I'm going to do is I'm going to work out this triangular face here. Okay, and what I've got is I've got the dimensions here of 4 centimeters with a height of 3 centimeters. Now my area of a triangle, so my area of my triangular face here, is going to be half of 4 multiplied by 3, because remember that let me go back to my spotty line. My triangle is actually just kind of half of that rectangular volume that I would have there, that rectangular area, sorry, that I would have there. So 4 times 3 is 12, divided by 2 is going to give me 6, and then I'm going to have 6 multiplied by 3, because that is my depth here, 3 centimeters, so 6 times 3 is going to give me a volume here of 18 centimeters cubed. Okay, I hope that's helpful. I will speak to you soon.